Hello, this is FlippedHarber for Algebra 2. In this video, we'll be covering Section 5.5, Complex Numbers and Roots. Our objectives for this video are to define and use imaginary and complex numbers and to solve quadratic equations with complex roots. The outline for this video, we'll start by talking about imaginary numbers. Then we'll move on to solving a quadratic equation with imaginary numbers. Then we'll talk about complex numbers. We'll find complex zeros of quadratic functions by completing the square. And then we'll end by talking about complex conjugates. Now, an imaginary number is simply the square root of a negative. What we do is we use the letter I as a stand-in for the square root of negative 1. So you can say that I equals the square root of negative 1. If we ask what's the square root of negative 25, well, the square root of 25 is 5, so that's easy. But because it's the square root of a negative 25, we let that I take the place of the square root of negative 1. So the square root of negative 25 is equal to 5i. The square root of a negative 15, since the square root of 15 doesn't work out well, it's an irrational number, we'll just leave it as the square root of 15. And we bring in that I to take care of the square root of the negative 1. So basically we just put the I at the end and we get rid of the negative under the square root. Now pay close attention to that I. It is not under the square root. Only the 15 is under the square root. Alright, something for you to remember. Since I equals negative is the square root of negative 1, that means that I squared has to equal negative 1. Okay, so let's use complex numbers in order to solve some quadratic equations. Use imaginary numbers. Complex numbers are a little bit different. We'll get to those. So let's take a look at the quadratic on the left. X squared equals negative 81. I'm going to go ahead and take the square root of both sides to solve this. Now, since we're solving an equation, when we take the square root, we want to make sure that we include both the positive and the negative. So x is equal to positive or negative square root of negative 81. A great time to use this I because we're trying to take the square root of a negative number. Well, square root of 81, no big deal, that's 9. But the square root of that negative gives us the I. So x equals positive or negative 9i. Let's look at the one on the right. 3x squared plus 75 equals 0. I'm going to start out just like I normally would. I'm going to move that 75 over. I'm going to divide by the 3, and that gives me x squared equals negative 25. Now, just like the one on the left, I'm going to take the square root of both sides. I'm going to get positive or negative square root of negative 25, which is equal to positive or negative 5i. So really not a whole heck of a lot different than what we've been doing before. Now let's talk about complex numbers. A complex number has both a real number and an imaginary number, and they're added or subtracted. So we talk about a plus bi. That's like the form that these complex numbers should take. The real number plus or minus the imaginary number. So 5 plus 2i. It's a great complex number. Negative 2 plus I. That's great. It's in standard form. But this last one, negative 4i plus 3, well, we should really be writing it as 3 minus 4i. We should always write complex numbers with the real part first. Now, finding the complex zeros of a quadratic function, what we're going to do is going to go ahead and complete the square to make this happen. Now, we talked about completing the square in the previous section. So we're going to go ahead and group the x squared minus 2x, and I've gone ahead and I've made a space for the number that I'm going to add inside the parentheses and the number that I'm going to subtract at the end. Now remember, you always add half of the b value squared. So I'm going to add 1 squared inside the parentheses, and on the outside I'm going to subtract 1 squared, which is 1. So I get x minus 1 squared plus 4. Now, I haven't actually found anything out about the quadratic yet. I guess I could say that put it in vertex form, but to find the zeros of this, I need to go ahead and set the function equal to 0. So I'm going to go ahead and move that 4 over, just like we did in the previous section. Just move that number over. I'm going to take the square root. Oh, well, we're going to be taking the square root of a negative number. So that's x minus 1 equals positive or negative 2i. Square root of 4, no big deal, it's 2. The I takes care of that square root of a negative 1. Now the last thing I need to do is go ahead and add my 1 over. So x is equal to 1 plus or minus 2i. This is two numbers, two complex numbers actually. It's 1 plus 2i and 1 minus 2i. You're going to find out that if you have one complex 0, the other one is a complex 0 as well. It's actually a property in math. Okay, now, these two numbers that we always get in pairs are actually what we refer to as complex conjugates. They're two complex numbers with a really simple relationship. They have the same real number, the same a, and they have the same complex number, that same bi, except it's plus bi in one number, it's minus bi in the other number. So these two complex numbers, a plus bi and a minus bi, are complex conjugates. Okay? And whenever you talk about complex conjugates, you kind of have to talk about the pair. You can't really say that this number is a complex conjugate. You have to say that the pair is a complex conjugate, are complex conjugates. Okay, well, let's go ahead and find some complex conjugates for these complex numbers. Now, negative 2 plus 3i, no big deal. Okay, there we go. Negative 2 plus 3i, no big deal at all. We just change the plus in front of the 3i into a minus. Leave the sign on the real number alone. Only change the sign in between them. Now you'll notice 2i plus 15 is not in our standard form. So it should really be written 15 plus 2i. So that means that its complex conjugate, I don't know where that is going, there we go, is 15 minus 2i. Now what if we have just a plain old imaginary number? Well, it also can have a complex conjugate. I don't know where these are going, but the complex conjugate of 4i is negative 4i. What about a real number, negative 3? There's no imaginary number added or subtracted from it, so negative 3 is its own complex conjugate. Okay, so why are these important? Well, they're going to be really important because when you multiply two complex conjugates, the result is always a real number. We're actually going to use that in a section a little bit later. But what you need to worry about right now is getting started on your homework. So good luck. I'll see you online and I'll see you in class.